Okay, so to stem off of my video on ionic charges, I'm now going to talk about ionic bonding. Okay? And first I want to talk about why atoms bond together, but then we'll kind of explain how it's connected to the charges. So, ionic bonds, atoms, okay, want two things. There's two things that they need to, like I said in the ionic charge video, to feel comfortable. Okay, so if they want to feel comfortable, they want to, be, comfortable doing what they do, they need two things. The first thing, right, is to have that perfect shell, that full shell. That's the one thing they like. Having those electrons is great for them, okay? They're stable that way, okay? Now the issue that we learned about in the ionic charging is, okay, is that when you take on a charge, you're no longer balanced, okay? So for instance, right, we were talking about Na, or we talked about lithium and how it becomes Li+. Okay, when it's charged, it becomes extremely reactive, which is something atoms don't like to be. They don't like to have to react. Okay, so the other thing they want is to be charge neutral. Okay, and that's a problem now for these atoms, right? They've got their full shell. They sacrificed, right, feeling comfortable for that full shell of electrons. But now they're not charge neutral, so they really need to find a way to neutralize their charges. Okay, otherwise they're going to react and they're going to feel uncomfortable, and that's not what atoms want. Okay, so their solution is what's called an ionic bond. Okay, and an ionic bond is when two ions, two or more, come together to balance their charges. Okay, now that's a really kind of an oversimplification of how it really works, but for our intents and purposes, yeah, that's what an ionic bond is. It's when two ions, two charged particles or more, come together, okay, and neutralize themselves for the greater good of all the parties involved. Okay, and so here let's do an example. Okay, here I've got sodium and chlorine. Okay, and like we learned in the charge video, they don't have the perfect number of electrons in their outer shell, so they are going to become ions to satiate that full shell of electrons. Okay, sodium is in the first column. Okay, and first column elements become +1. So Na is going to become an ion. Okay, +1 charge. He's got his full shell of electrons. Chlorine is short 1. Okay, so he's going to become a -1 ion. Alright, and now they both have their full shells of electrons, but they're no longer charge neutral, right? They each have a charge, they're unhappy. Okay? So what they're going to do is they're going to kind of meet up and they're going to say, hey, I'm +1, you're -1. Let's get together, let's bond, and hang out together. Become NaCl. Okay? And when we do that, we'll become a charge neutral compound. Okay, it'll be there's two different atoms coming together. They each have the right amount of electrons, and because they're together, their charges are balancing each other out, and then they become happy. Okay, I have another example for you, and this is magnesium and nitrogen. This one's a little bit more complicated. Okay, and I'll explain why in a moment. Magnesium, when it becomes an ion to get its perfect shell, becomes a +2. And nitrogen, when it becomes an ion, becomes a -3. As you can see, 2 and 3 don't match up. So like NaCl, they can't just plop together, right, 1 Mg, 1 N, and balance each other out. If they did that, there would still be a -1 charge. Okay? So that means sometimes, right, multiple ions of the same type will get together and form a compound together. So what they're going to need to do is they need to find a common denominator, or a common multiple, okay, of their charges that they can bond together with. So for instance, right, 2 and 3 are the charges. 2 times 3 is 6. That's a common multiple of those two numbers. So in the end, we need to end up with 6 charges over here and 6 charges over here. And if we do that, we'll be able to neutralize the charges. Okay? So if I have a +2 charge with the magnesium, how am I going to get to 6 charges? Well, I'll have 3 magnesiums. So I'll end up having 3 of them. Mg3. Okay, when you have multiples of an element in a compound, you put the number down below. Okay. Now for nitrogen, to get to 6 charges, they have a -3 charge, so we're going to need 2 of those to get to 6. So we'll end up having Mg3 and 2. Now, all 5 of these atoms have full shells. They're charge neutral. So all those atoms are going to be happy. Okay? So any ion that you come across can be rearranged and bonded together in a way to make it so that they all have their full shell electrons, and they'll be charge neutral, which is what everybody wants. Okay? Sometimes you're going to have big compounds like this. Sometimes they'll be really simple, like NaCl. Okay? So the key point to take away from this is that atoms need full shells, and they need to be charge neutral. Okay? That's the one key point. And the other key point is that it's okay to use multiple atoms to do this. Okay? So in the end, if we want to have an ionic bond, we're going to need 2 or more ions. They're going to bond together to neutralize their charge and be more comfortable.